Good evening students, welcome to Engineering Maths Guru. So students, in today's session we are going to discuss real matrices. So see the name of the topic, simplifying real matrices. So students, this is a very important, a relevant topic, a significant topic for GATE 2025. So if you are focusing, if you are from any of the branch, civil, mechanical, EC, electrical, instrumentation, computer science, data science, any of these branches, then this session is going to become an important for you. So students, we will be discussing simplifying real matrices. So I will be helping you what is in learning what is this real matrix, what are its various classifications, and definitely we will be going through some beautiful questions. So students, let's proceed. So this is the brief introduction about me. My name is Ankit Joshi and you are on my channel Engineering Maths Guru. I am having a teaching experience of more than 22 years and I have been teaching engineering maths since a long time. I have taught my topic many times and you will see that experience in my class. So students, stay tuned for the best of the concepts. Students, this is my Telegram channel's link. I think you will not be able to click it from here on your mobile. You can see the same link in the description box of this particular session. So from the description box you can copy this link and just join the channel Engineering Maths Guru. So Telegram group, this is our Telegram group and this is the link to join. The same link is being also mentioned in the description of this particular session. So stay tuned for best of the concepts and do join this channel, do join this Telegram group to have to download the classroom PDFs. So let's proceed. Students, one small information for you. There is there is an app named as Ankit Joshi's Maths Manthan. So I am owning an app for engineering mathematics, and on that app currently 2 days before I have launched a course for engineering maths for GATE 2025 and the name of the batch is Sankalp 2025. So all what you need to do, you need to download the app from the Play Store. The link for downloading the app is also given in the description box. And yes, how can you do from the Play Store? Either you can just open the Play Store, Google Play Store, and just type Ankit Joshi's Maths Manthan. There you will find the logo of Ankit Joshi's Maths Manthan. Just click on that, the app will be downloaded and there you can see the Sankalp 2025. And in case you do not find the link, then definitely you can contact us. So you can contact us at our contact number. So students, these are the various features of Sankalp 2025. I will be the faculty, I will be teaching there engineering maths. Batch already started on 6th of November. Course validity is up to 31st March. I will be covering the entire engineering maths in nearly 45 days from now. So students, these are the key highlights of Sankalp 2025 batch. This particular batch is available on our app Ankit Joshi's Maths Manthan. So 90 plus hours of live classes you can find there. You would be able to attend 90 plus engineering maths for 90 plus hours. Wow! Daily live class of almost 2 hours. Video recording of the lectures will be available. Classroom PDFs will be available on app. Chapter wise test I will be providing, and of course we will be having separate doubt clearing sessions. So let's proceed. Students, let us start our today's session, real matrix. So what do you mean by real matrix? A matrix in which all the elements are real numbers is said to be real matrix. ऐसा matrix जिसके सभी elements real numbers होंगे उन्हें कहा जाएगा real matrix. So students, real matrix means a matrix whose all the elements are real numbers. So you can see the example here. This matrix A is having elements 1, 2, 3, 1, 0, minus 7. All the elements are real number and that's why this matrix is real matrix. So this is a rectangular real matrix and this is a square real matrix. Let's proceed. Let us see the classification of real matrix. So on what basis these real matrices are classified? How this matrix A is associated with its transpose. A transpose A के साथ कैसे related है? Based on the relationship between A transpose and A, real matrices are classified into 3 types: symmetric matrix, skew symmetric matrix, and of course the orthogonal matrix. For symmetric matrix, the necessary condition is A transpose equal to A. If A transpose equal to minus A, it means it is a skew symmetric matrix, and if A transpose equal to A inverse, then it is an orthogonal matrix. So students, when we talk about the classification of real matrix, we just relate A transpose with A. If A transpose equal to A, then symmetric matrix. If A transpose equal to minus A, then skew symmetric matrix, and if A transpose equal to A inverse, then it is an orthogonal matrix. So this is how real matrices are classified. You know students, matrix multiplication is not commutative. It means A into B is not equal to B into A. Suppose A and B are two matrices, A and B are two matrices, you will find that A into B is not equal to B into A, and that's why we say that matrix multiplication is not commutative. So if matrix multiplication is not commutative, and that is the reason why we are having two different types of multiplication in matrix. One is called as the left multiplication, another is called as the right multiplication. So all my dear students, if I am having a matrix A and if I say left multiplication by B, left multiplication by B, what does it mean? Left multiplication by B means matrix A will get multiplied by B from left side, you will get BA. Now again you are having matrix A and I am saying I am doing right multiplication by B. So matrix A will get multiplied by B from the right side. Students, left multiplication is also known as pre-multiplication and right multiplication is also known as post-multiplication. Now let us discuss about orthogonal matrix. Students, as we already told that for an orthogonal matrix A transpose equal to A inverse. For an orthogonal matrix, if A is an orthogonal matrix, then A transpose will be equal to A inverse. I will be noting down this relation two times. मैं इसे दो बार लिखूंगा, A transpose equal to A inverse. And now I am performing certain calculations. I am left multiplying this, left multiplication by A, left multiplication by A, and here I am doing right multiplication by A. So all my dear students, A transpose as it is, A inverse is getting multiplied by A from the right side. Here A transpose, yes, what you are doing? You are multiplying A transpose by A from the right side. So A transpose into A, A inverse into A. Here A transpose into A, what you are doing here? Sir, here we are doing left multiplication. Okay sir. So A transpose gets multiplied by A from the left side, A inverse get multiplied by A from the left side. Okay. So A into A transpose equal to I. A transpose into A equal to I. All right. Yes sir. So can you see here, A into A transpose is equal to I, A transpose into A equal to I. So if we compare equation 1 and 2, if I compare equation 1 and 2, what I am getting? Right hand sides are equal to I, right hand side I के बराबर है, तो left hand side equal हो जाएंगे. So A into A transpose equal to A transpose into A equal to I. So this is the derived condition of orthogonal matrix. So when you say A transpose equal to I, this is the fundamental condition of orthogonal matrix, and from this fundamental condition, by the concept of left multiplication and right multiplication, you have derived the derived condition of orthogonal matrix, and this is A into A transpose equal to A transpose into A equals to I. All right, are you all following? Yes, I am moving to the next. Determinant of an orthogonal matrix. Just now you derived one condition. What is that condition? A into A transpose equal to I. For an orthogonal matrix, we can say A into A transpose equal to A transpose into A equal to I. From this equation, I am considering only the first part. A into A transpose equal to I. A into A transpose equal to I. So students, if I take determinant both sides, so I will be getting this expression, and A into A transpose determinant, we can separate this, so we can get determinant of A into determinant of A transpose, and determinant of I, as you all know, that it is always equal to 1. So all my dear students, you just note down in your minds that determinant of a unit matrix is always equal to 1, and determinant of A is always equal to determinant of A transpose. You can just take any example and try it yourself, and if you have any doubts, let me know. So determinant of A transpose is equal to determinant of A. So all my dear students, both of them are same, so I just write determinant A as it is, determinant A transpose is again determinant A, and this is equal to 1. So all my dear students, we are getting determinant A square equal to 1, and determinant of A will be square root of 1, that will be either plus 1 or minus 1. So I would like to make a statement that for an orthogonal matrix, the determinant values can be either plus 1 or minus 1. If you are having an orthogonal matrix, then its determinant value will be either plus 1 or minus 1. There is no other value of determinant existing for an orthogonal matrix. Now, what do you mean by proper orthogonal and improper orthogonal? When it comes to the classification of orthogonal matrix, there are two types of orthogonal matrix. Number one is proper orthogonal and number two is improper orthogonal. So proper orthogonal is that orthogonal matrix for which the determinant value is 1. If the value of the determinant of an orthogonal matrix is 1, then it is called as proper orthogonal, and if the value of the determinant of an orthogonal matrix is minus 1, then it is called as improper orthogonal matrix. So these are the conditions for an orthogonal matrix to be proper orthogonal or improper orthogonal matrix. Mind my words, keep in your mind that it does not mean that if any matrix having determinant value plus 1 or minus 1 will be orthogonal. No, not at all. What is the concept? If you are having an orthogonal matrix whose determinant is plus 1, then it is proper orthogonal, and if your orthogonal matrix is having determinant minus 1, it is called as improper orthogonal. That's it. Now, skew symmetric matrix. Students, we have to perform an element level analysis for skew symmetric matrix. Let us say we are having a matrix A which is A of ij. I just assume that this matrix A is A of ij. Is that okay? Yes. Now, what do you mean by A transpose? So A transpose will be AJI. Very good. Now, what is the condition for a skew symmetric matrix? If A is a skew symmetric matrix. If A is a skew symmetric matrix, then A transpose equal to minus A. I can also write this as A equal to minus A transpose. भाई minus sign को इधर लेकर आ गए. So A is equal to minus A transpose. Now what is the element level representation of A? A को क्या लिख सकते हैं? A can be written as Aij minus A transpose क्या है? What is A transpose? It is AGI. So this is the general condition for any element of a skew symmetric matrix. Now what is the condition for diagonal element? Diagonal elements की क्या condition होती है? For diagonal elements, tell me, I is equal to j, row number is equal to column number. Let us put this in equation 1. इसको हम रख देंगे equation number 1 में. Equation 1 में रख दिया. We just substituted this in equation number 1. So what we got? Aij will become Aii. I and j both are same. Aii equal to minus Aii. If you bring this term to the left hand side, you will get 2 times Aii. Arey bhai, both the terms are same. This is minus. When it is brought to the left hand side, it will become plus. On the right hand side, 0 will be retained. So Aii is nothing but 0. What does it mean? Diagonal element is 0. For whom? For a skew symmetric matrix. For a skew symmetric matrix, always the diagonal elements are 0. Skew symmetric matrix के diagonal elements हमेशा 0 होते हैं, and for off diagonal elements they will satisfy this condition. So I am going to write an element level definition for skew symmetric matrix. So Aij is an element of skew symmetric matrix. Yes sir. So this element will be 0 if we are talking about diagonal, that is I equal to j. I equal to j is the condition standing for the diagonal elements, and if I say I am not on the diagonal, it means I is not equal to j, I is not equal to j. Under that situation, this elemental condition will be followed, that is minus aji will be followed. Tan, tan, tan. So when you talk about a skew symmetric matrix, then its diagonal elements will be compulsorily 0 and off diagonal elements will be minus of aji. Alright, let's proceed. I want to write few examples of skew symmetric matrix. So matrix A, let us say it is a skew symmetric matrix. Diagonal elements are compulsorily 0 and off diagonal elements are just connected with a minus sign. If this is 2, this must be minus 2. Alright? Yes sir. Another example. Now this time 3 cross 3 is skew symmetric matrix. So diagonal elements are compulsorily 0. This is A12 and this is A21. They are just connected with a minus sign. If this is 5, this is minus 5. A13 and A31, they are connected with a minus sign. If this is 10, this is minus 10. A23 and A32, they are connected with a minus sign. Yes sir. So if this is 1, this will be minus 1. So these are few examples of skew symmetric matrix. Alright, just have a look over this and just comment in the comment box, is everything all fine? So let's proceed, students. Now the element level analysis of symmetric matrix. When we talk about symmetric matrix, what is the elemental condition? For symmetric matrix, A transpose equal to A. We can also write this as A equal to A transpose, and A can be replaced by Aij, and A transpose is nothing but Agi. So student, this is the elemental condition. For diagonal elements, I equal to j. So I equal to j means aii equal to aii. So we know that aii is equal to aii, but does it mean any condition imposed on the diagonal element? Not at all. क्या इससे diagonal elements पर कोई condition impose हो रही है? नहीं हो रही है दोस्तों. इसका मतलब symmetric matrix के लिए diagonal elements can be any real numbers. They can be 0 or non-zero. For diagonal elements can be any real number, and for off diagonal elements, they are satisfy the condition. Which condition they will satisfy? Tell me. Aij is equal to Aji. I will share this PDF on my Telegram group, Engineering Maths Guru, whose link is given in the description box. Students, I want to construct an example of symmetric matrix. Yes. Diagonal elements can be any real number, and off diagonal elements are same. Another example. Diagonal elements can be 0 or non-zero, positive or negative, any real number. Off diagonal elements are same, 2, 2. If this is 5, this is also 5. If this is 7, this is also 7. That is the logic. So this is how a symmetric matrix is being constructed. Now the various important properties of matrix, symmetric matrix and skew symmetric matrix. See, if A is any matrix, let it be neither symmetric nor skew symmetric. If A is any matrix, A is any matrix, neither symmetric nor skew symmetric. Then A plus A transpose is always symmetric. A में A ट्रांसपोज ऐड करेंगे तो हमेशा सिमेट्रिक मिलेगा, एंड A माइनस A ट्रांसपोज is always skew symmetric. Always remember, if A is any matrix, then A plus A transpose is always symmetric and A minus A transpose is always skew symmetric. Will you remember this? You have to. Now, any matrix, any square matrix can be split into two parts. Any square matrix can be split in two parts: symmetric component and skew symmetric component. Any matrix, any square matrix can be split into two parts. One is the symmetric component, another is the skew symmetric component. So students, symmetric component is A plus A transpose by 2, and skew symmetric component should be A minus A transpose by 2. And the beautiful part is that when you add these two, again you will retain the original matrix. So any square matrix can be split into two parts. One is the symmetric part, another is the skew symmetric part. What is that symmetric part? Symmetric part is A plus A transpose by 2. याद रख लो, A plus A transpose by 2. और skew symmetric part क्या होगा? A minus A transpose by 2. Now, next property is, if originally you have skew symmetric matrix, if A is a skew symmetric matrix, if A is a skew symmetric matrix, then what? Then what about A raised to K? A raised to K can be symmetric or skew symmetric, depending on what? Depending on K. If K is even, if K is an even number, then A raised to K is symmetric. If K is an odd number, then A raised to K will be skew symmetric. All fine? Can I have your response? Come on, fast. So if originally A is a skew symmetric matrix, then A raised to K will be symmetric if K is even number, and A raised to K will be skew symmetric if K is an odd number. If originally A is a symmetric matrix, then A raised to K will be always symmetric for all values of K, for all integer values of K, for all positive integers we can say, yes. So A raised to K will be always symmetric for all integers. All right. So 2 points we made here. If originally A is a skew symmetric matrix, then A raised to K depends on whether K is even or K is odd. If K is even, then the result is symmetric. If K is odd, then the result is skew symmetric. But if originally A is a symmetric matrix, then A raised to K will always be symmetric. All right. Let's move to the next. Eigenvalues of symmetric matrix it should be. So students, eigenvalues of symmetric matrix are always real numbers. Eigenvalues of symmetric matrix are always real numbers, and that's why they have to be plotted on real axis. So on real axis we plot the eigenvalues of symmetric matrix. Eigenvalues of skew symmetric matrix are pure imaginary, and that's why they have to be plotted on imaginary axis. Eigenvalues of skew symmetric matrix are always pure imaginary, and that's why they find their place on imaginary axis. Eigenvalues of orthogonal matrix will have their magnitude 1. Orthogonal matrix की eigenvalues का magnitude हमेशा 1 होता है. What does this represent? This represent the distance of that coordinate from the origin. तो यूनिट सर्कल के ऊपर जितने भी पॉइंट्स हैं उनका ओरिजिन से डिस्टेंस 1 है, एंड दैट्स व्हाई आइगन वैल्यूज ऑफ ऑर्थोगोनल मैट्रिक्स फाइंड देयर प्लेस ऑन यूनिट सर्कल. ऑर्थोगोनल मैट्रिक्स की आइगन वैल्यूज यूनिट सर्कल पर प्लॉट करते हैं. वी प्लॉट द आइगन वैल्यूज ऑफ ऑर्थोगोनल मैट्रिक्स ऑन द यूनिट सर्कल. स्टूडेंट्स, you will get direct question in GATE based on this frame. This is very important for you. Lock my point. Very important concept. Students, there are three types of real matrices: symmetric matrix, skew symmetric matrix, and orthogonal matrix. So eigenvalues of symmetric matrix are always real numbers, and that's why on real axis we plot the eigenvalues of symmetric matrix. Now another classification of real matrix is skew symmetric. Skew symmetric matrix is a real matrix, but its eigenvalues are pure imaginary. They have to be plotted on imaginary axis of argand plane. Orthogonal matrix, yes, orthogonal matrix eigenvalues have magnitude equal to 1. Eigenvalues of orthogonal matrix have magnitude equal to 1. ऑर्थोगोनल मैट्रिक्स की आइगन वैल्यूज का मैग्नीट्यूड हमेशा 1 होता है, एंड दैट्स व्हाई दे हैव टू बी प्लॉटेड ऑन द यूनिट सर्कल. ओके, दिस इज अ वेरी इंपॉर्टेंट फ्रेम, very important frame, very important concept for upcoming GATE exam as well as your ESE prelims. Now few questions. One more point I want to make. If A is any matrix, रहने दीजिए, A कोई भी मैट्रिक्स हो, A सिमेट्रिक भी नहीं है और स्क्यू सिमेट्रिक भी नहीं है, लेकिन जब हम A इंटू A ट्रांसपोज करेंगे तो ये हमेशा सिमेट्रिक होगा. If A is any matrix, neither symmetric nor skew symmetric, but you will realize that A into A transpose is always symmetric. A into A transpose is always symmetric. And what is the statement here? If A and B are real symmetric matrices of order n, then which of the following is true? For symmetric matrix, A into A transpose equal to I. No, this is the condition for orthogonal matrix. A equal to A minus I. No, this is a blunder. Matrix multiplication commutative? No, never. AB transpose equal to B transpose into A transpose. Yes, true, correct. Okay, yes. So AB transpose equal to B transpose into A transpose. When transpose operation is separated over matrix multiplication, reversal law will be obeyed. B will come first and then A comes. So B transpose into A transpose. See this question. They already mentioned that Q is an orthogonal matrix. For an orthogonal matrix, Q transpose is equal to Q inverse. Q transpose is equal to Q inverse. What they are asking? The inverse is, they are asking us the inverse of Q. Inverse of Q क्या होगा? Q का transpose होगा. अरे भाई, orthogonal matrix की condition क्या होती है? What is the condition for an orthogonal matrix? Transpose of the matrix is equal to inverse of the matrix. So Q transpose will be equal to Q inverse. We want Q inverse. What is this Q inverse? It will be transpose of Q. So how to take the transpose? First row will become first column. So find the matrix whose first column is 3 by 7, 2 by 7, 6 by 7. 3 by 7, 2 by 7, 6 by 7. Yes, first column. Second column is second row. अरे भाई इसका ट्रांसपोज लेना है ना. Second column is second row. Minus 6 by 7, 3 by 7, 2 by 7. Correct. Third column is the third row. 2 by 7, 6 by 7, minus 3 by 7. 2 by 7, 6 by 7, minus 3 by 7. So we can say that for the given orthogonal matrix Q, the inverse, which option is correct? Tell me. So option C is the correct one. नाचते गाते लगा दीजिए, just strike option C. Okay sir, we got it. Yes or no? Yes sir. If A is a real square matrix, just now I discussed this point. If A is a real square matrix, then A into A transpose is always symmetric, always symmetric. Option B is the correct one. Option B is the correct one. Let's proceed. If a square matrix A is real and symmetric, रियल सिमेट्रिक मैट्रिक्स की आइगन वैल्यूज कैसी होती हैं? आइगन वैल्यूज आर ऑलवेज रियल, आइगन वैल्यूज आर ऑलवेज रियल, आइगन वैल्यूज आर ऑलवेज रियल फॉर सिमेट्रिक मैट्रिक्स, आइगन वैल्यूज आर ऑलवेज रियल। ओ भाई, आइगन वैल्यूज ऑफ सिमेट्रिक मैट्रिक्स आर रियल नंबर्स, skew symmetric matrix have eigen values pure imaginary numbers, and for orthogonal matrix magnitude of the eigen values is 1, and that's why they find their position on unit circle. Consider the matrix. Which of the following statement is correct? So all my dear students, this is an orthogonal matrix without any doubt. Orthogonal matrix. And for an, so how this is orthogonal matrix? Just wait, I will teach you that trick also. So if this is an orthogonal matrix, then its transpose will be equal to inverse. Now they are asking for which of the following statement about P is incorrect. I guess they are asking for incorrect, that word is missing. Okay, so P transpose, okay, I am saying that this is orthogonal matrix, I will explain also, don't worry. So P is orthogonal as of now, this is correct statement. Inverse of P is equal to its transpose, this is also correct statement. And for an orthogonal matrix, determinant is either +1 or -1, so this seems to be correct. So what is that condition which seems to be wrong? All eigen values of P are real numbers. For an orthogonal matrix real number नहीं होती ना eigen values, eigen values lies on the unit circle. Unit circle पर अगर eigen values है तो complex भी हो सकती हैं. So this is wrong. So here the answer is the option which is wrong. Now sir, how you initially guessed that this is an orthogonal matrix? Now please see here, what are the numerators? See the first row, first row देखिए, what are the numerators? 1 0 1. See the second row, see the third row numerators, -1 0 1. Now calculate one factor, 1 square plus 0 square plus 1 square, this is called as norm. Calculate the same here also, calculate the same here also. So I just listed the numerators, then I am calculating the norm of each of the numerators. So here I am getting √2, here I am getting √1, that is 1, here I am getting √2. Now students, if I divide this numerator by this norm, what I will get? If I divide this numerator by the norm, what I will get? 1 by √2, 0 by √2 and 1 by √2. Is it the first row? Is it the first row? Say yes or no. 1 by √2, 0, 1 by √2. Yes. So if I divide these numerators by 1, what I will get? I will get the second row. I am getting, am I getting second row? Yes, 0 1 0 is the second row. -1 0 1 divide by √2. Is it the third row? So if this mapping is, if this condition is satisfied, if this trick is satisfied, then without any doubt you can say that this is an orthogonal matrix. So for an orthogonal matrix, P transpose equal to P inverse, inverse of P is equal to its transpose, this is correct. P is orthogonal, that is already verified. Determinant of P is equal to 1, you can calculate the determinant, you can calculate the determinant also, and after calculation of determinant you will realize that the determinant is 1, not -1. So student, all the eigenvalues of P are real number, that is the incorrect statement, and here in this question they are asking for which of the following statement is incorrect. So option D is my answer, not the other ones. Okay, yes sir. So option D is our answer. Okay, let's proceed, let's move to the next. A real square matrix A is called skew symmetric. भाई कोई भी मैट्रिक्स स्क्यू सिमेट्रिक है तो उसका ट्रांसपोज -a के बराबर होगा ना, ये ऑप्शन सी, वन लाइनर क्वेश्चन। और इसीलिए मैंने कहा था कि जो फ्रेम्स आप देख रहे हैं यू विल गेट डायरेक्ट क्वेश्चंस फ्रॉम दोज फ्रेम्स। स्टूडेंट्स, सेशन अच्छा लग रहा हो ना तो लाइक कर देना, कंजूसी ना करें, जस्ट मार्क योर अटेंडेंस विद दैट लाइक बटन, और थोड़ा मेरी बात अगर मान लें तो इस सेशन के लिंक को शेयर कर दीजिए अपने सारे ग्रुप्स में। Just share the link in all your contacts, in all your groups. Tomorrow also I will be coming up one beautiful concept, one beautiful question. बहुत छोटा सा सेशन लेता हूँ, 40 मिनट का सेशन, 40 मिनट सेशन will going to give you 1 mark, 1 question in GATE, upcoming GATE exam. Now this one is again an important one. If A is a square matrix which is neither symmetric nor skew symmetric, एक ऐसा मैट्रिक्स है जो सिमेट्रिक भी नहीं है, स्क्यू सिमेट्रिक भी नहीं है. There is a matrix which is neither symmetric nor skew symmetric. So we formed a matrix S which is the addition of these two. So S is the addition of A and A transpose. भाई ये तो सिमेट्रिक होगा, S is symmetric without any doubt I can say. We already learned the properties, and D is the difference, A minus A transpose. This is skew symmetric. So S is skew symmetric, that is wrong. S is symmetric and D is skew symmetric. Option D is the correct one. Are you following? Already we discussed the same property. Next. See this question. The transpose of the matrix is equal to the inverse. Achha ji, transpose of the matrix is equal to inverse. What does it mean? 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 Transpose of the matrix equal to inverse means this is an orthogonal matrix. This is an orthogonal matrix. And for an orthogonal matrix, what is the condition? Matrix into its transpose will be equal to unit matrix. ओहो, ये तो हमने सोचा ही नहीं था. मैट्रिक्स M और उसके ट्रांसपोज को मल्टीप्लाई करने पर आपको यूनिट मैट्रिक्स मिलेगा दोस्तों. तो ये रहा M, उसको M ट्रांसपोज से मल्टीप्लाई कर देते हैं. What is M transpose? 3 by 5 and X, and 4 by 5, 3 by 5. First row become first column, second row will become second column, and this must be equal to 1 0 0 1. I want to calculate X, मुझे X चाहिए. So first row into second column, I am performing this multiplication and equating it to 0. So बच्चा लोग 3 by 5 into X, 3 by 5 into X, and 4 by 5 into 3 by 5. 4 by 5 into 3 by 5 equal to 0. So this is minus 12 by 25. हाँ जी, एक 5 कैंसिल कर दीजिए, एक 3 कैंसिल कर दीजिए. So minus 4 by 5 will be the answer. X is minus 4 by 5. Yes sir, option A is the correct answer. So all my dear students, this is all about the classification of real matrix. Tomorrow, in tomorrow's session, we will deal one very important concept from probability. So probability का एक बहुत ही important concept लेकर आऊँगा, ठीक है? Just subscribe this channel if you have not done so, so that you will get the notification, and also join my Telegram group. और आज का इस सेशन में एक announcement already मैं कर चुका हूँ. I will repeat that. Sankalp 2025. This is my course. I have launched this course on my app Ankit Joshi's Maths Manthan. You can just type this in the Play Store. Ankit Joshi's Maths Manthan. Just search this in Play Store. You will get the link of our app. You can directly observe the download link. You can directly find the download link from the description of this particular session in the YouTube channel also. So engineering maths for GATE for all these branches: computer science, civil, mechanical, EC, electrical, and instrumentation. Batch already started on 6th of November. Recorded sessions are also available. Every day 2 hours of class is there. You can take the advantage of this, and currently the course is running at a discount. So it's a 90 plus hours of course whose fees is 3600, and currently you can get the course at the price of 2800, 2890 hours of classes. Okay, so definitely you will enjoy the sessions. So all my dear students, this is my Telegram group, Engineering Maths Gurus Telegram group, and this is the download app link. So student, this is the customer support contact number, and of course this is the mail ID. So you can have the screenshot of this. So thank you so much students, love you all, take care, stay happy, stay safe. Jai Hind, Jai Bharat, Jai Maharashtra. Tomorrow, see you soon. Bye bye. Thank you.